For the first part of the experiment, we determine the electrolyte conductance and ionic mobility of different types of solutions. The different types of solutions are ammonium chloride, hydrochloric acid, sodium chloride, sodium acetate, and sodium hydroxide. We transfer 20 ml of each of the seed solutions into a small beaker separately. Then, we measure the conductance of each of the electrolyte solutions by immersing the electrode in the solution. For the second part of the experiment, we determine the dissociation constant of a weak electrolyte. Here, we will be preparing 6 different types of mixture with different volume of potassium hydroxide and water, as shown in the table. Then, again, we measure the conductance of the mixture prepared by using an electrode. For the treatment of results, calculate the concentration of potassium hydroxide in each of the mixture prepared. Then, tabulate the concentration in the conductance of potassium hydroxide solution.
Now we have the equation of line, which substituting the conductance on Y, we find X. Write the chemical equation for the dissociation of ammonia into ions in aqueous solution. Using ice method, we get K is equal to the right reaction over the left reaction, which is also equivalent to X times X over 1 minus X. The X value was determined using the graph earlier, which is 2.372 times 10 raised to negative 3. Then substitute it to here, we get 5.64 times 10 raised to negative 6, which is the dissociation constant of ammonia solution. Then the percentage error is equivalent value minus the true value over the true value times 100, giving us 68.66%. After computing the dissociation constant, based on the table, the concentration of ammonium hydroxide is decreasing, while the conductance and dissociation constant are both increasing. In fact, the larger the concentration of ammonium hydroxide, the lower the conductance is. It is mainly because it's a weak electrolyte, which does not undergo complete dissociation, unlike the potassium hydroxide. Moreover, by dilution of a weak electrolyte, the degree of dissociation of the electrolyte increasing, resulting in an increase of ions produced, and so the conductivity of the compound increases.